Inequality can take one of these forms that I've already written down. It's either going to be the quadratics greater than 0, greater than or equal to 0, or less than 0, or less than or equal to 0. And solving a quadratic inequality is a bit like solving a quadratic equation, except there's a little bit of an issue where if we just find the roots, we don't know whether it is greater than or less than these roots. So there is a little bit of a method. But so if we draw a quadratic, we can either draw one going like this, where that means that a is positive, or one going like this, which means that a is negative. Now, if we want the quadratic in this case to be bigger than 0, we're just looking above the x-axis because it's above the roots. And in this case, then this quadratic would be greater than 0 when x is bigger than that number going to the right, or less than that number. But it would be below the x-axis when it's in between these two. And similarly, for one that's upside down, the quadratic is greater than 0 between these two roots, but it is less than 0 to the left and the right. And for each question, all we'll do is find the roots, draw a picture, and just look where it's above or below the x-axis. So example 1 says, solve x minus 3x plus 5 is greater than or equal to 0. So the first thing we do is just find our roots as normal. So to find our roots, we make it equal to 0. And this is a simple one. That means that x equals 3 or x equals minus 5. And now this is where the solution changes for higher maths. So we know our roots. So if we just draw a quick sketch of this quadratic, it is a U shape. And we've got minus 5 on one side and 3 on the other. And then just to solve our quadratic inequality, we just go back to the original question and said, greater than or equal to 0, so I'm thinking about it being above the x-axis. Well, this quadratic inequality, this quadratic's above the x-axis, that side, and that side, because in between, it's below the x-axis. So I can just write down that x is less than or equal to minus 5, or x is greater than or equal to 3, and that's our two solutions. So in quadratic inequalities, example 2 says, solve x squared minus 4x minus 21 is less than 0. So the first thing we always do is examine our roots. Just do our national 5 stuff. X squared minus 4x minus 21 is equal to 0, which means I can hopefully factorise this. X and x, 7 and 3. Minus 7 plus 3 is minus 4. So x is equal to minus 3, or x is equal to 7 as our roots. So we can now draw a picture. We've got minus 3 on one side. That's just a quick sketch, 7, and we'll just draw our parabola. There's our 7 there, so let's just move that because I've just messed our drawing up. Y and x, and the question's asking us, when is it less than 0? Well, less than 0 is below the x-axis, here. In other words, between minus 3 and 7. So we just write minus 3 is less than x, is less than 7. And don't put the equals ones on it because it's not in what and equals, it's just what and when it's less than. And we're done there. Solving quadratic inequalities, example 3. Solve 4 minus 9x squared is less than 0. Okay, so we want our roots. So our roots are 4 minus 9x squared is equal to 0. Well, that's the difference of two squares. So I can just factorise that straight away. 2 minus 3x, square root in it, and 2 plus 3x equals 0. So that means 2 minus 3x equals 0, or 2 plus 3x equals 0. Solving the left-hand side one, 3x equals 2, so x is 2/3 is one of our roots, or 3x is minus 2, so x is minus 2/3 for our other root. Drawing a quick sketch. So we've got it between minus 2/3 and 2/3. Now you need to get your shape right. It's a negative 9x squared, so it's a upside down one. So we'll draw it upside down. And then we say it's what we want it to be less than 0, so it's below the x-axis. Well, this one's below the x-axis to the left and to the right, because in between it is above. So we can just say that x is less than minus 2/3, or x is greater than 2/3, and that's us done it. Solving quadratic inequalities, example 4 says, find the values of q such that this quadratic has non-real roots. If it's not got real roots, that means that b squared minus 4ac is less than 0. b squared minus 4ac is less than 0 for no real roots. So we just then sub in b squared minus 4ac. So there's my a is equal to 1. There's my b in front there, and there's my c. So I've got q minus 4 squared minus 4 times 1 times a half of q. And we're going to solve that to be less than 0. So we've got a quadratic inequality, hopefully. Q squared minus 8q, and 4 4s are 16. And then 4 times a half is 2, so that's minus 2q, and that's less than 0. So that's q squared minus 10q plus 16 is less than 0. And we can see if we can factorize that. So double brackets, q and q, 8 and 2, minus 8 minus 2 makes minus 10, is less than 0. So a quick sketch on the side, minus 8, minus 2, there's a quadratic, and we want that to be less than 0. So that is below the x-axis, so that's in between these two numbers. So we can just say that minus 8 is less than q is less than 2. Solving quadratic inequalities, example 5, where is y equals a half, a third x cubed plus 2x squared minus 5x plus 3 increasing. Okay, so this kind of combines quadratics or polynomials with differentiation, because we know that a function is increasing when the y by the x is greater than 0, means it is increasing. Remember, if it equals 0, it means it's a 0 gradient, and if it's negative, it means it would be decreasing. So the y by the x, that is 3 times a third is 1, x squared. 2 2s are 4, plus 4x, minus 5, and we want that to be greater than 0. So we can just solve that quadratic inequality. X and x, 5 and 1, plus 5 minus 1. So our roots are x equal to 1 or x equal to minus 5. So we can draw a picture. It's a positive x squared. So let's put a minus 5 and 1. My pictures are very inaccurate, but it doesn't have to be accurate because it's just a quick sketch. Want to be greater than 0, it's above the x-axis. What's above the x-axis? This side, because it keeps going that way, and this side. So that means that x is less than minus 5, or x is greater than 1. And we're done there.